Don't love that. What happened when this was a squared? What did I tell you to do if this was a squared? If this was like x equals x squared, and I told you anytime you see a squared, you're probably doing something. Factoring. So what I would suggest that you do is move everything to one side. Minus x, 0 is equal to x cubed minus x. Now, when I factor, the first thing I always check for, and I'm going to make a little note, check for GCF. And I see, do my terms have anything in common? Do they have anything in common currently? An x. So I'm going to come in, I'm going to take an x out, and I'm going to be left with x squared minus 1. This was one of our special case factorings, and I'm going to write it out because it's probably been a while since you've seen it. If I have a squared minus b squared, I could factor it to be a plus b, a minus b. So when I see that factoring, or that binomial, x squared minus 1, it's going to factor into x plus 1, x minus 1. So I'm going to have 0 equals x, x plus 1, x minus 1. Now the reason why I wrote it out this much is because you actually have 3 answers for this problem. There's 3 factors that we're setting equal to 0. So I'm going to come in, I'm going to set x equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. For the first one, you don't have to do anything. One of your answers is x equals 0. For the second one, if I subtract 1 from both sides, x is equal to negative 1. And then for the third, if I add 1 to both sides, I'm going to get x is equal to positive 1. So if you happen to look at a problem and you notice, there's nothing I can do at this point, I would probably try moving everything to one side to see if it's factorable. You didn't necessarily have to divide by the 8 to do this. You could have left the 8 there and still factored out an 8x and gotten the same exact answers. You cannot divide by the variables, because then if I had divided by x in one of those initial steps, I wouldn't have my answer x equals 0, and that is one of them. It has to be there. So make sure if you're dividing by something that they have in common, it's just a number and not a variable itself. Yes? Yes, that's fine. As long as you have all 3 listed, that would be fine. You could have boxed them all together if you wanted to. Okay, last problem. Told you today's going to be short and sweet. We are going to go in. We are going to cube the left side. We are going to cube the right side. Now, before you go in and you take that cube and you distribute it to the 2x and to the minus 1, I want you to remember what I said about you cannot do it if you have addition or subtraction. So simply because this minus is here, I cannot just say 2x cubed and 1 cubed. I can't do it. What you have to do for a problem like this is you need to take 2x minus 1 times 2x minus 1 times 2x minus 1. We are going to cube all of those binomials together. Personally, I kind of take it in parts. So the first thing I'm actually going to work with is, and it doesn't matter which 2 you pick, I'm just going to pick these 2 so I can keep my parentheses at the front. I'm going to go in and I'm going to double distribute. So when I double distribute, I really don't do anything special. I just go in and I take first to first, outside to outside, inside to inside, last to last. As long as everything gets multiplied together, as every combination is multiplied together, we're good. So I'm going to say 8x cubed minus 1 is equal to, I'm going to leave these parentheses alone, 2x minus 1. And then 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. And then -1 times -1 is +1. I like to come in and combine like terms before I even move on to the next step. So this is actually going to give me 8x cubed minus 1 equals 2x minus 1, 4x squared. The only thing I can currently combine are the two x's together. So I'm going to have -4x plus 1. Okay, now here's where you kind of have options. One, you could just go in and take the 2x, distribute it to all three terms. You can take the -1, you can distribute it to all three terms, combine like terms, which is perfectly fine. I will say usually in multiplying a trinomial times a binomial, we get messed up based on organization. So you may remember, and this may be helpful, it may not, it kind of depends on what you prefer. You may remember your teachers kind of talking about a box method, where if you make a box, and if you don't want to do it this way, you don't have to. And I'm going to split this box into 6 sections, 3 on the top, 2 on the side. The reason why I do that is I'm going to take every term that I have, and I'm going to write it in one of these sections. So like 4x squared, I'm going to have -4x. I'm going to have +1, and then I'm going to have 2x, and I'm going to have -1. You actually could do this for 2 binomials as well if you prefer that, but usually that multiplication isn't as complicated and you're not combining as many things together. So it doesn't necessarily always need the box method, but if you wanted to, you could. So then what we do is I'm going to take each intersection. So like the 4x squared and the 2x are going to multiply, and whatever I get from that, I'm going to put in this first box. So I'm going to have 4x squared times 2x is going to be 8x cubed. And then whatever order you go in is completely up to you. I'm just going to go across to the right. -4x times 2x is -8x squared. And then 1 times 2x is 2x. And then I'm going to drop down, and then I'm going to have -4x squared, +4x, and then a -1 times a +1 is a -1. And what this kind of helps us do is make sure that we have all combinations present when we start combining like terms. So I'm going to have 8x cubed minus 1 is equal to, I have 8x cubed, there's nothing that it's being combined with, but if I look, I have a -8x squared and I have a -4x squared. So I'm going to combine those two terms together, and I'm going to get -12x squared. And then I'm going to do the same thing, but I'm going to do it this time for my 4x and my 2x. Because they share a common variable, we can combine those two terms together, and I'm going to get +6x, and then you have your -1 that has nothing that it's working with currently. Now, once you're here, you just have to kind of get everything to one side. The first thing I'm going to point out is if I come in and I take 8x cubed and I subtract it from both sides, it's basically going to go away. 8x cubed, 8x cubes, they're gone. The same thing can happen for the +1 and the +1. They go away. They're gone. And you're left with -12x squared plus 6x. And again, anytime you have an exponent, whether it's x squared or x cubed, the best thing that you can try to do at that point is try to factor it. Check for a GCF, see if you can pull something out and see if you can factor it further. So do 12x squared and 6x have anything in common? What do they have in common? 6x. Now you can just pull out 6x and that would also work. I'm going to actually pull out the -6x. It is not going to make a huge difference. So I'm going to have 0 equals -6x. And remember, when we have a GCF, it's like you're going in and you're dividing every single term by that GCF. So when I have negative 12x squared divided by negative 6x, I'm going to get 2x because negative 12 divided by negative 6 is positive 2, and x squared divided by x is x. And then when I have positive 6x over negative 6x, that's going to give me a negative 1. Another common mistake that we see for problems where you're factoring is people will say 6x over 6x is 0. If you see the same number in the numerator and the denominator, it's equivalent to 1. It doesn't just completely cancel out and go away and disappear. So I have 2x minus 1. Now at this point, I don't have anything I can factor. 2x minus 1 is not a squared, it's not a cube, I can't do anything to it. So what I'm going to do, and I'm going to point this out just so you know it's going to work exactly the same way, I'm going to take each term that I have, including the GCF, I'm going to set it equal to 0. Because if I come in and I try to get this by itself, I'm still going to end up with an answer where one of my solutions is x equals 0. And then for the other one, add 1, 2x equals 1, divide by 2, x equals 1/2. And the nice thing, again, about these cube root equations is you don't have to check your answers. Yes, you could. You could take each of these answers, plug them into the original, make sure you got it correct. If you have extra time on your test, that's not a bad thing to do, but you don't have to. It's not a part of the grading that we see. Did they check their answers? So I'm going to come around. You are going to get your